Welcome in, everybody. Sorry about the snafu with the starting the stream early. We'll be here in just about 6 minutes, and that's when we'll get started. In the meantime, I'm here. I'm in the chat. If anybody has questions or they want to talk about anything, I'm happy to get started chatting. But bear with us just for a few more minutes, and then we'll get here. We'll get started. Thanks, y'all. Hey, everybody, again, letting folks in as they get into the waiting room. My name's Alex. I'm here to answer questions y'all have or anything like that. So bear with us for a few more minutes and we'll get started. I'm going to go ahead and open up the chat now if anybody wants to introduce themselves. Will should be here in just a couple minutes. Anybody who feels comfortable, wants to join in the conversation, feel free to turn your cameras on, and I'll save you a little grief. Will ask you to do the same thing once he gets here anyway. So might as well get him on now and introduce yourself in the chat. Maybe say where you're from. Love to see where everybody's tuning in from. We'll get started in just a couple minutes.
Stop the clocks. Everything is about to change because we are about. Hello, Christopher. Good to see you. That's right. We are watching. Hello, Angelo. Hello, Sanai. Sanay. Hello. Angelo's in New York. Hopefully I can make myself co-host. Do you mind doing that for me, Alex? I think you have to make me co-host. Otherwise, I can't unmute. Or do I? Are you not host, Alex? Do I need to make myself a co-host? Oh, we have to do it. Okay, let's have a look. Hold on. I don't think if you're host, I don't think I can make myself. I think Alex, you have to make me host or co-host or something like that. Maybe I'm wrong, actually. I don't know. Hello, Chris.
Oh my goodness, the debacle continues. Hold on, Will. I will unmute you.
Hooray, people, we're off. And as always, people, let's make sure the hooray, people. Hey, I'm on the YouTube as well. Good. So let's make sure that where is the host tools? There it is. Enable waiting room, turn it off. There we go. Good to see people. But feel free. I mean, the only problem with I need to start screen sharing now. Otherwise, what happens is poor Chris, their face is the only thing that shows on the YouTube stream right now. So we don't want to do that to wonderful Chris, delightful Chris, though your face certainly is, and it really is very nice. We don't want to do that to you, Christopher. So let's dive in to how to get hired in. We just make sure my stuff is ready in 2024. Soon we'll be renaming this with all the creativity and call it How to Get Hired in 2025 because it's, well, it does change, isn't it? So we're going to talk specifically how to get hired in 2024. Here we go. Screen on. Put in the chat, people, where you are in the world. Chada, welcome back. Omnia is in Egypt. Excellent. Christopher is in, Regina is in New York. We love it. We have folk in New York, in Jacksonville, Florida. Thank you, Christopher. That's lovely. All right, people. So we will dive in. In personal news, I've been reading the 4 Pillars series. Very good. Very good. I enjoy the monks up to no good or up to good. Very entertaining. If you are looking for some entertaining, what's it called? The Pillars of Earth. Here we go. Very, very entertaining. If you haven't read it, and if you're into monk debauchery, then that will be your thing. Okay, here we go. Here we go. We're going to dive in with how to get hired as a software engineer. I'm very lucky to have my co-host here, Alex. If you do get, I'm going to open the chat, people, so you can. Oh, you're already open the chat. If you want to, if anyone DMs you, people, with untoward or unpleasant commentary or soliciting, what is it? Loitering. If anyone loiters in your DMs or solicits in your DMs, please message me so we can kick them out. Okay, so we're talking today about how to get hired in 2024. We will dive in a moment, and we're going to cover what it is to be a great engineer. So how to get hired as a software engineer. Well, what is a great software engineer at this point? We will talk about where can you do it? Yeah, you want to get hired, you need to know what you're getting hired for. What is a software engineer, effective software engineer today? Where are you going to get hired to do it? Why would you even do it? It's not a gold rush. Really, at the moment. It's obviously not bad, but it's not a gold rush per se. And how do you get paid to do it? And I hope I'm relatively qualified. People, feel free to turn your cameras on if you want to. You're very welcome to. I love it when I get to see your beautiful faces. Right now, I only have Christopher, who's clearly on a trek across a golf course right now. And so unless someone else turns their camera on at some point, I will get distressed at only having golf course Chris. Oh. Okay, so no notes in the camera on. But we're going to base all this sort of stuff off the kind of approach to jobs in software engineering that achieved these great outcomes for Codesmith alums in the last 2 months. So, these are great outcomes for Codesmith alums. Actually, this was 119. That's been amended. It was actually 119, 119. But it's some really cool companies: Pinterest, JP Morgan, Amazon, Palantir. There's the person who went to AWS. So what are the things which Codesmith's doing that you can all do without going to Codesmith? Or if you're trying to get into Codesmith, good luck. But what are the things you can all do to achieve these sorts of outcomes in a market that in theory it's harder to achieve these sorts of outcomes? So let's talk about how you can do that. This is based off all the history of Codesmith's insights, but obviously, these are results of the last just 2 months. So we should hopefully be able to learn some stuff from that. So we'll do that and do that together. But quickly, some words about Codesmith. I think one of the reasons those outcomes are achieved is Codesmith focused on building modern software engineers. That's the kind of engineers who are flexible to things like changing tools, rapidly changing tools. At this point, we've talked for many years about the full stack engineer. Full stack means you can do front-end stuff, you can do back-end stuff. Now, full stack increasingly means you can do front-end stuff, you can do back-end stuff, and you can do AI stuff. That's going to be things like integrating, at least if you're not yourself configuring, at least integrating and working with machine learning engineers to integrate prediction. Prediction is the ability to say, based on past data, which might be all the words of the internet, make predictions for future, which might be person asked question, predict what's the best answer to it. That's prediction. It's a whole new part of the stack that is to be a software engineer, integrating prediction into your products. Like front end is about making things show up and interactive on the screen. Back end is about saying, where's all that stuff that shows up on the screen coming from? ML AI is about saying a lot of these products involve using prior data to make insightful, almost human level insights and reasoning. How do you integrate those? So that's the kind of modern engineer. And software engineers who are part of that are the conduit, they're the flow, they're the channel, they're the faucet converting needs of organizations into software products. And that means a range of software engineering roles. That means product engineers, that means product reliability engineers, that means front-end engineers, that means AI engineers, that means the recent grad who I mention every week because it is so interesting, who got a software engineer lawyer role. Her job required 2 years of Python backend experience, which, essentially means be good at Python, and have been a lawyer. What an amazing modern software engineer we're seeing. So what's that look like? Well, in terms of the things that make a great modern software engineer, there are 5 things we consider. I'm not going to dwell on them too long because we're going to see them in the workshop in terms of how to be an effective engineer to get hired. But briefly, the 2 most important are: how do you take difficult challenges and wrestle them into some structure, problem solving? How do you help other people understand how you're doing that, technical communication? What are the principles that guide you doing that, engineering approach? How do you collaborate with others on doing that, non-technical communication? And what expertise do you bring to doing that, domain knowledge? Okay, pre-Codesmith, the goal is that you've done enough prep that sure, you need to package up a portfolio, but if you did, you could get at least a baseline developer job. If instead you choose to try and get into Codesmith, then there's 2 versions of the program, both of which afterwards you should be targeting an autonomous software engineer, not a bootcamp grad, but a autonomous software engineer or starting your own thing. So what are these grandiose claims built on? 3 pillars. 1, a teaching style that's not original. In fact, they're the same teaching style that honestly I was fortunate to get in my undergrad, particularly one that's built on you becoming owner of the concepts that you work on, not a reciter, not a regurgitator, but an owner. You understand the underlying mental models that enable you to solve any new problems in that domain. As a timeless teaching style that's not original, but it's done on contemporary technology. Last night there was a workshop on heuristics, prompting heuristics. So prompting is let's call it, prompting can be thought of as a stochastic, that means probabilistic, programming language. It's instructions for a computer that are not prescriptive. They're not every syntactic, that means every little comma or whatever you change stops it working. Instead, it's stochastic. It means there's a probabilistic chance it will work or not, right? When you prompt to generate code in Copilot or anything like that, it's fundamentally a probabilistic thing. Will it work or not? One aspect, therefore, of integrating LLMs into workflows, AI models into workflows, is what are the heuristics, what are the mental models around a programming language that is non-deterministic. Prompting to a LLM is a programming language. It's using text code to interface and control a computer's actions. However, it is non-deterministic. It's not like code where if this, then that, then do this. It's instructions that may or may not generate the intended result. That creates a lot of opportunity, allows for far more flexible data models. For example, you don't need to have your data structured perfectly. It can interpret. However, it also creates all sorts of new challenges because you're now dealing with the kind of unpredictability that comes with that. Great and problematic. So what are heuristics around that? And then finally, a community, which is the thing I'm most proud of, perhaps, at Codesmith, which is, yes, you've got the #1 schools going into Codesmith being, some of these fancy schools, but also a whole range of backgrounds. So we won't dwell on those here, but this is how it's done. This timeless pedagogy, which the key thing for all of you, because it speaks to you as engineers and aspiring engineers or current engineers, is a software engineer is not limited. You are not a COBOL software engineer. You are not a React software engineer. You are a software engineer, meaning you will figure out the tool, whatever it may be, for the job. Over half of grads in their first rollout do not use the language that Codesmith teaches, TypeScript or JavaScript. That's very salient. That's very important. Technology, frontier tech, you've got Alex here, who is one of the leads in machine learning at Zoox. I was reading about the CEO of Zoox, and she sold it to Amazon for 1.3 billion. She ran Intel's team of 7,000 in, I'm not quite sure which division, do computer engineering in, I want to say, Paris, and very interesting CEO. And one of her team is the co-founder of Codesmith, who wrote the book on deep reinforcement learning, or reinforcement deep learning, and talks here about the involvement that they have in our ML/AI curriculum as part of the software engineering program, but these are the kind of things that they therefore achieve, like contributing to TensorFlow.js, its pre-processing image layer, or image pre-processing layer, built by Codesmith students. Wild. And then, yeah, anyway, there's the one of community. Note, people, again, the fact that the largest major going into Codesmith is computer science should tell you something. There's something going on. There's something that in getting hired, that you are looking to do that may not be in that computer science degree. You know, otherwise, why would someone do computer science and then go to Codesmith? Well, there's a bunch more things that make a great engineer and that maybe you unexpectedly wouldn't always attribute to being a great engineer, and then how you communicate those. So we'll talk about those today. All things you can do as someone who didn't go to Codesmith. This is gonna, by the end of this workshop, you'll have a list of assignments that you can do independent of Codesmith. Okay, achieving these sorts of outcomes, these are offers from 2023 to 2024. You've got people there like software engineer lawyer, this person here doing, again, Fusion kind of analytics front end at Netflix, a very classic pure software engineer at Snapchat here, Madeline, who went to Snapchat 12 months ago or so. Actually, I'm doing a fireside chat with Cyrus here. I'm really excited for it. Cyrus is a senior engineer at Tesla, straight out of Codesmith, and is on Friday. We're doing a podcast fireside chat live stream, which you're welcome to come to. I'm not sure it's even on calendar, so I'm not sure how you can see it. I don't even know if it's on calendar. Let's have a look. I doubt it is. I bet it's not. Hold on. Nope, that's not very helpful, is it? So look out on the internet on Friday for a fireside chat, me and Cyrus. So you can go to my LinkedIn and I guess you can see maybe but that will talk about how to build a career as a software engineer as well. There you go. There's you can, if you want to, I don't know how there's no link to any place to RSVP. So I guess just get lucky. So there we go. All right. For all of you aspiring to Codesmith or not, enjoy this free community, this prep community. You've got here someone like Isabel, who went on to be a data scientist at Meta. And I think I had a lovely quote here. I did exactly what Codesmith laid out in the How to Get Hired workshop, interviewed at Meta and Google, played them off each other for salary negotiations. So very nice comment by Isabel, and she agreed to be featured in this. So I appreciate her. Admissions process, you can go to info session. Efforts here. On the note, an iconic computer scientist, people, Lynn Conway passed away, died three days ago. So if you're interested in learning about the history of computer science and also interested in learning about someone who was pioneering in many more ways than just even alone being a groundbreaking computer scientist in the things they developed, go and look up Lynn Conway as someone who is, I'm sure you saw, so significant as to have trended the highest voted article on Hacker News in a long time, announcing the loss of Lynn Conway to the programming community 3 days ago. So something to open all of our eyes to. And then here's the great academic team. And there's me. And let's look in the chat because I'm about to pass to... Oi, Jay. It's been 17 minutes. And unless you want to pay me personally for this workshop, you can put up with that. Very entertaining, Jay. Get out. All right. Very entertaining, Jay. Unless you're personally leading workshops, getting people hired, Jay, you can keep your comments to yourself. All right. Excellent. Is Jay still on? Are we allowed to just boot people out? No, I won't do it. All right. Excellent. So, Alex, if you want to share a little bit about how you can help people before we dive in, and then we can make the call on whether Jay's comment is something that I want to put up with or whether Jay can be removed from this. Maybe Jay is going to send a little note saying, but thank you, Alex, for your lovely patience. I no longer feel that sort of thing when I'm doing a free workshop on how to get hired and someone says, excuse me, how long is this going to take? And it's like, Jay, unless you run your own How to Get Hired workshops, you keep your comments to yourself. All right, good. Over to you, Alex.
This is part of the pre-content too, so bear with it. Hey, everybody. First of all, I'm sorry for the wild opening to this thing with a blank screen for 17 minutes with occasionally my camera turning on. I was still new at live streaming. So my name is Alex. I am a graduate of Codesmith and a software engineer. I am a UX engineering director at a robotics company. And I'm mostly here tonight just to answer questions. I'm also happy to connect during and after this session if you want to talk more about the Codesmith experience or making the bridge into tech. I came to Codesmith with a completely non-technical background. I owned a organic flower farm for a decade before attending Codesmith. So I am happy to share my experience with you, happy to answer any questions, honestly, frankly, openly. And in the meantime, I'll just be here making silly comments in the chat. So feel free to reach out. I'll put my contact, I put it in the chat earlier, and I'll put it again before the meeting's over. But welcome, everybody, and let's connect.
Amazing. Thank you, Alex. Lovely to have you on. And people, as I dive in now to talking how to get hired as a software engineer, as I say, 4 big parts of it. What is a modern software engineer? Where can you do it? Why would you do it? And how does one go about getting paid to do it? As we do that, can people put in the chat now that everyone's here? Can you all put in not just where you're from, where you heard about this workshop and where you're at in your engineering journey? So are you someone who's done a computer science degree and is now trying to get hired? Are you someone who's been laid off and trying to re-enter? Are you someone who's aspiring to Codesmith and just mapping out what engineering path looks for you, where you're at, and from what platform you found this, because it gives me context as I tailor the talk to all of you. So please throw in people where you're at in your coding journey. You know, graduated CS, you know, never thought about coding until today, software engineering for 10 years, taking a pause, or software engineering for 10 years, in job right now, but want to get a new role and prepare for that, you know, these sort of things. And then where you heard about the workshop, meetup, Codesmith community, CSX, just throw in the chat. I'm still seeing no messages, so type faster. All right, here we go. Let's dive in. Here we go. So what we're going to cover today, what makes a great modern software engineer, where you can do it, why you'd do it, and how you get paid to do it. Starting with what makes a great modern software engineer. So we'll start here with what might seem like the most obvious part of it, which is the tech, the tools, and the languages. Actually, we're going to see in a moment, this is only a fifth, 1 out of 5 areas that make a great software engineer. We could call it domain knowledge, the knowledge of stuff. But these are the areas to be aware of. Front end, that's the stuff that shows up on the screen and how you write code to make stuff show up on the screen and make it interactive. You can click stuff and it changes. Sounds, I don't know, maybe it sounds quite simple. Actually, it's profoundly complex in modern applications because everything you see on the screen has to actually be a reflection, mirror / projection, a projection of underlying data. You may see the number 7 on a tweet, describing the number of likes on that tweet, and you may click heart and it goes to 8, but those are just pixels on the screen. There must be a data value, the number 7, in your computer to which 1 can be added to make it 8. And then that has to be projected onto the screen, appended to the DOM, displayed as pixels through a rendering engine. Actually maintaining consistency between the underlying data, known as state, the truth of the application and what the user sees, when the bloody user can change what they see the whole time and therefore implicitly must be changing the data, the state, very complicated, very fast. That's front end. The web systems are all the pieces that enable that, whether it's the browser environment where you write the code to, or it's where you add stuff to be displayed, the DOM. Where's all that data coming from? Well, it ain't on your computer, right? When you open Twitter, it's not on your computer. It's coming from Twitter's computers. That's the server. Serves up, provides that. And then there's a lot of tweets saved there. That's the databases. Computers tailored for storing a lot of data. How do you get all that code that's going to instruct those computers what data to store, how to get it back quickly to be displayed to the user? How do you write that code to do that when it's maybe going to sit on tens of thousands of computers? If you only had one computer at Twitter's headquarters, then if I open Twitter and another 100 people do it at the same time, it may not be able to handle it. If I've got 10,000, now it can handle maybe many users. How do I write the code to ensure it works across all those computers, all in tandem, in conjunction? That's our infrastructure. That's things like containerization, allowing us to capture units of computation ability as programmable things that can be instructions can be written for. Things like Docker and Kubernetes allow you to think about a whole computer running as something that can have instructions written for its running, a container. How do you make sure that the most important resource in an engineering team, you, the engineer, the developer, is able to do so as quickly, performatively, effectively, reliably as possible? Developer tooling. This is things like Git to allow you to share that code and maintain its changes over time. Scripting to allow you to interact with your computer in a more automated manner than just typing or using the mouse. And then here's the really exciting new bit, people, that I was sort of sharing earlier. You got front end, you got back end, you got ML adjacent, you got AI. So this is not you becoming an ML engineer per se, and it's certainly not you becoming a data scientist. It's a different role. A data scientist's job is to, with a scientific inquiry, try and explore what best model gives you the best outcome in your prediction. What's the most accurate prediction? That's not then turning that into a product. That's where the ML engineer comes in, but also the software engineer working with an ML engineer, and often working instead of an ML engineer, not every company has them, on integrating that prediction. I don't think we're going to see a slide. Yeah, it's a different workshop where we talk about what does that team look like. But specifically, it's if you had Apple's new AI tool that allows you to proofread text. In fact, it's specifically within a text editor, allows you to right click and go, hey, make this sound better or more formal, correct the grammar. The prediction of that, what would be the good text that is better than the text the user drafted, the prediction of that was made by the data scientist. They often did that on their own computer in an experimental manner. The ML engineer got that prediction probably live and made sure it didn't cost too much money to make, performant. The software engineer integrates that prediction. That is to say, the user starts writing something, right clicks in Apple's AI, Apple Intelligence, and goes, make this sound better or proofread it, and generates a better version. The software engineer has to take in the user's data they've written, the messy text, return back, make the call to the API, return back the formalized data. Actually, with Apple, it might be done locally on the machine, but the same principle applies. And then that's not just it. They may even have to try and improve the prediction in future, so it doesn't end up like Siri, by the user's changes to the improved version being useful information about what the prediction should have been. The software engineer is going to be doing all of that, like snapshotting the user's changes to be passed back to the ML engineer, the data scientist. That's all the ML adjacent stuff. What I was describing there is called data or model pipeline. It's the flow of data between the user, the prediction, the engineers, and then the user's experience again. Okay, and then presumably you're going to choose a programming language, maybe just one, to do all this stuff. Okay, I'm going to come back to that. But you need to be a great software engineer in this era, aware and able to flex in any of these areas. And you want to be T-shaped. T-shaped meaning be solid across all of these. I could work it out if I had to. If I had to go and take on Azure, which is Microsoft's cloud platform for deploying applications, then I could do that. Not me, but like one could, right? But you want to be T-shaped in that, not just solid across the board. You want to be really good in one lane or two lanes or three lanes, but like, you know, like the stem of the T. Solid knowledge, super deep on one area or two or three. So whatever that is for you, you might want to really understand JavaScript as a runtime, specifically asynchronicity, lexical scoping. Somebody tweeted today a really cool article that was not tweeted, sorry, did this thing that was about one of the core principles of JavaScript closure. If you can really understand how execution context, closure, these things work, not only does it come up all the time in interview, but even when it doesn't, you're going to end up bringing it up because you're passionate about it, you have a deep understanding. We're not here so much talking about how to sell yourself, but rather what makes a great engineer. Being a T-shaped developer is a great thing for a team. It's amazing in your team of 10 people if you've got somebody who's an expert in each area and everybody's pretty good across the board. That allows it to be that, when your colleague needs to understand, why is this function not calling? And you're able to explain, you didn't realize, or why is this value undefined? Better example. Why is this value undefined? You didn't realize how lexical scoping or closure is working. Okay, so you want to be an expert in one area. Great. All this to say, surely you have to pick your language, right, to be a great engineer? I'd argue no. When I look at the second big category that makes a great engineer and gets you hired, it's this ability to think universally across technologies, tools, languages, and instead lean on the principles. And I think the reason I feel this is if you look at just even the last 500 offers for Codesmith graduates, over half of them were not in languages that Codesmith graduates learn. They don't learn Go, they don't learn Python, they don't learn Java, and yet over half of them, their offers, and you could say that's a failing, why are we not teaching? Well, you can't learn it all because you're not really coming to Codesmith to learn a language. You might as well learn one really well. You're really coming to learn underlying principles. So more important people to being a great software engineer than a lot of people in the chat might be saying, I want to learn Python. Sure, you might as well learn one really, really well. And you might as well make sure it's one you certainly want to learn one really well because you're learning the principles there. Oops. But much more important is, are you learning those principles than, should I learn? I mean, there are languages more suited to certain roles. Like if you're doing data science or ML engineering, you're going to need to know Python. But look at all these people going from Codesmith who didn't know Python and did Python roles because it's deeper than that. You need to instead focus on what happens when code runs. Posh word being execution. What happens when code runs? What really happens under the hood? For that, I'd encourage you to go to the hard parts of programming workshops. You can RSVP here. How do you structure your code? What is it that gives you the why as well? Closure, for example. Why the hell you have closure? Because some smart programming language designers went, we know that everything you do in app development is basically data and functionality. Data being like, data is a lot of stuff. It can be the number of likes on a tweet, but it could also be, is this box selected, true, selected, false, selected, true, selected, false. That's data, right? Functionality would be user clicks, box, change state, change data from selected false to selected true. Now run code to change from selected true to selected false. You might as well have that data and functionality really close together. OOP, object-oriented programming, lets it be by putting them in classes or instances of classes. Like using the structure, the description of how the data and functionality work together and then creating specific cases of it. Closure says, you're going to still need to refer to those by dot notation maybe, or maybe private variables not, but we're going to give you the ability to have functionality run and have the data it needs available by its name, but only inside that function. The point I'm making there is that is answering the question of encapsulation, keeping your stuff close together and not allowing it to be interfered with from anywhere else. So a lot of the principles of programming languages like JavaScript or Python or any of them are really answers to deeper design goals of you as engineers. So you can see how it's more important to understand those than the specific language, which is always an implementation, an effort to try and implement the underlying principles that make your life as a developer easier, longer term. Okay, code quality, making it usable for other people, and then making sure it works without breaking and or being really inefficient as you get lots of users or lots of team members or lots of code. Okay, so this is even more important than the language you choose. Okay, we almost have what makes a great modern software engineer. It's your tools and technology. These are the ones. Don't get worried if it's Java or JavaScript per se, or obviously don't, know the difference, but like pick one, dig in, because that's going to enable you to understand principles of programming, dig into those. And then it's to say that actually, you know what? This is the engineering approach and principles. This is the programming knowledge and tools and tech. There's actually three other things. One is problem solving. This is the ability, and it sounds so generic. Oh, problem solving, great. I can't write, I'm a problem solving engineer and apply with that. No, you can't. So anyone's just going to go, show me. But you can show them it. And it is ultimately what makes a great software engineer. The ability to take any problem, any domain, and ultimately figure it out. That is the crux of being a great engineer. As important is, can you help others understand how and why you're figuring it out the way you are? Those two together are what are the essence of a modern software engineer. I won't dwell on the non-technical. That's kind of the can you work with others thing. Just because, or it's not really, that's technical communication is can you help others understand and explain or whatever. This is the are you a decent, fair-minded person kind of thing, but I'm not going to prescribe that to anybody because we all have different versions of that, right? So not prescribing anything on that, but these two people are the essence of what makes a great engineer. And we're going to see in a moment that if you can show these, people want to pay you. And I know this from hiring, oh my God, I post a lot of jobs on various platforms, mostly nowadays, not LinkedIn, but other platforms, tech adjacent, software engineering roles. And my goodness, all you want to see, all you're hunting for is this person going to have the problem-solving flexibility to truly understand, and dedication, we're going to see in a second, to understand my problems, where me as an engineering manager, me as a principal engineer, me as a product manager, whatever, I barely understand them myself because I will need to delegate the understanding of the intricacies of what can be done in the tech, in the code to you. And until I understand what you're doing and you help me understand it and you help me understand my own problem, I barely understand it. Now you might be like, well, of course, a principal engineer understands. They do and they don't. They understand the overall architecture, but you will be the expert in implementing your bit of it. No doubt about it. So this is the key feature. And then the other thing I'm looking for when I'm hiring is, will they help me understand what they're doing? Both so I can ensure it's right, but also because without that, it's all about trust. It's all about my confidence that you are actually going to do your job, because I don't fully understand the details. So your ability to explain it to me helps me guide you as an engineering manager or whatever, but also helps me trust you're doing it right and you're doing it at all. And that's why these two things are so critical in getting hired as a software engineer, because not only are they vital to being good at the job, they also, if you do them, show the company who's hiring you, show the hiring manager, show the engineering manager, whatever, they show them that you care. They show them that you're going to try. We're going to see in a moment when we reach these slides down here, how do you get paid for doing this? We're going to see there that there's two things they're hiring for. One is, are you a great engineer? These 5 things. The other is, are you going to be bothered to bring all your talent to bear on my problems? Are you going to try hard? And in a really frothy market, maybe you can get away with not being reassuring to them you're going to try hard. In this market, half of what they're hiring for is, am I going to get the person who's going to really bring their all? Here's the badass thing about these first 2 things. These first 2 areas, they reaffirm for somebody, you will bring your all. Because if you do these things and have experience doing them, they know that you are the kind of person who tries really hard. Because solving difficult problems as an engineer and explaining them to other people are emotionally draining things. They're hard. And as we've learned from ChatGPT, things that are easy stop being effective. So if it's easy to generate on ChatGPT a cover letter, it stops working because people aren't really selecting for your cover letter. Did you do one? They're selecting for what was the effort that went in, because it's a proxy, an approximate measure of how much effort you will bring to the job. So the problem with all this is, problem solving and technical communication. How the hell do I show that when applying to a company? Well, that's what we're going to look at in the how to get paid for this. Like, I know how I can sort of say, hey, look at my portfolio of websites built in React. I know what that looks like. Actually, that's not very effective, because what they really want to see is problem solving and the ability to explain how you did it, complex decisions. And that is what they're hiring for. The crux of this workshop is going to be how, at each stage of the application process, can you show to the company who's interested in you that you are capable of these two things, that you have experience with solving difficult engineering problems and explaining to people difficult technical concepts, because that's what's going to make you a great engineer. Okay, we're going to come back to it on how you're going to show that to people so that it's not vague, and so that you're definitely never, ever, ever going, hey, in your application, I'm a really good problem solver, because the reader just goes, anyone can say that. So how do you show that? By the way, we'll see in a moment, once you're in the on-site, you'll show it by doing it. For whatever it's worth, engineering interviews are definitely a bit, not ideal, but at least they do require you to do the thing you'll do on the job. Like, they might have you debug a code base, a collection of code. There, you're going to have to show your problem solving and your technical communication. How do you explain the choices you're making? But damn it, when you're applying and they're reading your application for 2 seconds, how the heck do you show these two things? That's going to be the crux of what we cover in these dark green slides here. How do you show them from the moment you enter the admissions process that you are not only a great engineer, but that you're one that is committed to solving their problems? Okay, so let's just summarize, and let's just check the chat for questions and hopefully comments on people's journeys. Yay, fab people, lots of comments. Thank you so much, everybody. Okay, so just to summarize before we do check on the comments. So a great modern software engineer is above all about your ability to take complex problems that the business has, the user base has, the CTO has, the principal engineer has, and convert them into solutions in software via primarily code, but also meetings with others, also configuration files, also agents, in theory, a dev and AI kind of thing, all about converting the need into also, to do that really well requires ability to break down the complex problem, define what's possible within the technology, and explain that conversion to all people involved, including your colleague engineers. That's what you're being hired for. And your knowledge of engineering concepts, principles, and your knowledge of given technologies. Ideally, where you have some expertise in at least one of them, because that ensures you can become expert in anything. Okay, so before we continue, we're going to touch then on where can we do this. We're then going to talk about why would we do this, and then how you get paid to do it. But let's quickly check people here. Thank you, Paula. We've got in San Francisco through Meetup. I love it. Recent grad. Thank you, Nuran. In Egypt, amazing. Heard from the software WhatsApp community. I love it, Nuran. San Jose, 2024 college grad. CS, Giselle. Very cool. And minor in math. You should talk to Matthew Xing, Xing, who was a part-time program fellow, that's our TAs as well, who was CS and math at West Washington. Asheville, Carolinas, political science, making a shift. Heard from Googling boot camps. Shashwat, that's great. So still early in the journey. Well, then for someone like you, Shashwat, look at these early pieces here as giving you a map of the things you want to do. Fab, Niranjana, mid-level, great. So Niranjana, it can actually be a bit of a shift where you are already established mid-level, as you say, and then you're like, shoot, I'm seeing jobs and they don't quite match my role or my background or this technology or whatever. So it's even more important for you, Niranjana, to recognize which bit of your job you're really going to be hired for on the next job. And it's actually these abstract concepts like breaking down complex problem. The problem is, Niranjana, is you can't tell people that. You have to show it. So we'll talk again, how do you show that when you're applying? When you're interviewing, it's a different story. You can definitely show it. When you're applying, how do you show it? Love it, Loretta, welcome. Bojan, meetup, 10 years. Wow, Bojan, literally describing exactly what I was describing there, 10 years of experience, looking for new gigs. Again, Bojan, we'll talk about this, but particularly for someone like you, it can be very, I don't know your exact background, but it can be very easy to go, well, I'm an authority on, let's say it's Golang. It's, you know, probably not, maybe it's Golang, and before that, C++, who knows, or maybe it's JavaScript, whatever. And then you look at the roles, you're like, well, I can't play that one. You absolutely can. The need you're going to have to show is, and we'll talk about how you do this, is recognizing the universality of the tools you've used. If you've worked with some given specialized, and again, I don't know, Bojan, your own background, but like Oracle database, what are the universal database design principles that you can speak to that in an on-site, an engineer is going to go, of course, Oracle 10G database. I don't care if it's that or something else. You're thinking about SQL database design. But recruiters are a bloody pain in the ass in that if they see Oracle 10G database and they're, well, we're using Postgres. So just Bojan, particularly when you've got sort of a wealth of experience, being able to package that in a way that tells a great story about it being universal is really important. So maybe you want to DM me your LinkedIn and we can just check up on how you're doing that. Ryan, sweet. Oh, very cool. Boston DevOps. I did spend some time in Boston. Not my favorite. Great data analyst moving to software engineer. Fab. Sean's new to software engineering, so Sean sees this all as a map. Site grad Timothy. I don't know if you saw that the number 5 or whatever input into Codesmith was sites. That's cool. Okay, I'm going to try and keep going quickly. Great, love having you on it, Angelo. Thanks, Omar. Lol, it's very kind of you. I'm sure you're far more credible than me, Omar, I promise you. Love it, Loretto, you shared that, that's great. Kerrick's asked a specific question here. Alex has given some answers here, so I won't dwell, but honestly, I haven't looked at Alex's answer here, but I'm sure it's the same sort of idea. They're on a spectrum. A library is probably not going to be as prescriptive as to how you use it. Typically, a framework will say, we're going to, within this pre-written code, give you as many of the things you need to build this app. And we've probably made some decisions on how we're going to let you do it. Because if we want it to all work together, all the different pieces work together, we can't give you too much choice because then it won't all work together. So we're going to give you a bit more prescription, a bit more kind of command and control on how you use it. They call that being opinionated. So a framework might be more or less opinionated. Famously, React was initially, I would argue, very unopinionated, at least on the surface, in that you could do things a lot of different ways. You could have functional components. I guess it's probably still quite not opinionated. You can do them a lot of different ways. Traditionally, Angular, at least an old version of it, was very opinionated. You must, in fact, it literally, scope is the programming word for, in any line of my code as it's running, or any line, in any moment in my code, what data is available that I can reference. If I wrote like, I don't know, stored data value 1, that's a horrible example. Tweet 1, if I refer to my code, would that tweet be stored in memory available in data at that moment? That's scope, the rules around what data is available. Angular, despite being built in JavaScript and being like a framework in JavaScript, literally overrode the default rules in the programming language about what data would be available at a given moment. Overwrote the scope properties. I didn't literally overwrite them, but create an alternative scope that is the amount of the data that's available. So that's a very prescriptive or opinionated framework, Carrick. A very unopinionated library would be one that allows you to just use one function to do a little task. So huge spectrum. Okay. Love it, Chuck. Well, welcome. I would strongly suggest staying very involved in the community. Yeah, Sene, we can definitely share the slides. Loretta, how many projects does one need to have done before getting a job? Just very specifically, Loretta, what I would recommend is 4 or 5 full stack, which now might, as I say, include full stack would include front end, back end, infrastructure, good dev tooling, deployment, so infrastructure, deployment, putting it on the internet. Ideally with some light users who are breaking it, so you have to tweak. That means also infrastructure, and so it also means dev tooling in terms of error handling, fixing problems, this sort of thing. Making pull requests to change the code base. Probably 4 or 5 of those. And sorry, I'd also say ML integration, maybe on a few of them now. And by the way, ML integration, don't be intimidated. Go to the new hard parts of LLMs, which gives you underlying mental models. It's on the events page. Maybe Alex can share it to get the mental models of it. And then you can just start playing with tools like LangChain, Loretta, that allow you to integrate prediction, LLMs, into large language models into your apps. So I would say 4 or 5 of those, and then one potentially really substantial project. Maybe you have a family business that you can build the application for end to end. Maybe basically one where, Loretta, if it doesn't work, you got a problem. Now that doesn't work maybe because the users are really annoying and they keep double tapping the thing they should have just clicked once. Yeah, and that's engineering. Preventing those edge cases, that's engineering. So I would argue you need at least one of those. How you can fake that, because I say fake it because if you're not employed, how do you do it? Because that gives you users when you're employed. That's why you're being paid, because users are paying or whatever, someone's paying. So how do you fake that? Well, it's maybe working for a nonprofit. It may be going for like Hack LA. It may be doing open source work, which surprisingly, because you have to solve, when you build tools for other developers, open source tools, you have to yourself go so deep on how they work, you end up working on the kind of complex edge cases you'd work on with users. So find that way, Loretta, to kind of hack your way to having done some really hard, real engineering. And then for projects maybe that are more like for you, but still end to end. Okay, Loretta. Oh, Alex has answered all these questions. Okay, I'm going to answer questions because Alex has answered all these questions. Thank you, Bojan, for sharing the LinkedIn. I'll make sure to review that and email you. Okay, people. Here we go. Here we go. Here we go. Here we go. So now let's talk. Where can you do it? Well, the big breakthrough, people, is that since the tech recession of 2022 to 2023, please keep throwing questions in the chat. Thank you, Loretta. If you feel uncomfortable to put it in front of everybody, please send it directly to me. Okay, and then if you feel uncomfortable doing it at all, please feel free to tweet it at me. I'll just send you my Twitter here. If you don't feel comfortable even DMing it here, or feel free to connect on LinkedIn and ask and post it there. If you don't feel comfortable doing it otherwise. Okay, so get your questions in, people. So where can you do it? Well, essentially now, anywhere with the lessening caveat, because it is getting less of a caveat, but with the lessening caveat of probably not at the big tech firms, because, and we've got a whole talk on the tech market that's worth putting on your calendars if you see it or coming up in one of the workshops, a whole talk on what happened in the tech recession, a whole confluence of different things went down, but one of them was COVID led to an unprecedented hiring, particularly by big tech firms, that even though they've done multiple rounds of layoffs, has still not come close to offsetting the amount of hiring they did, meaning they're still able to move people around within their teams to fill the gaps as they start to invest in new areas again. That's not true of all the other companies, and it's especially not true of a whole category of firms who get value out of building software for its user benefit and or revenue and or cost savings today. So big shift in the last 2 years has been from the kind of software you build that will make money 5-10 years from now, particularly because if you build software to sell to others 5-10 years from now, it may allow you to make an 80% profit on that software because the product's built. Yes, there's maintenance, whatever, but it doesn't cost much to sell Adobe Photoshop to the next user. They make $160 off it per year just for the base level, and it costs them $7 to maintain, produce, and support. It's an incredible thing called software gross margin, 80% plus, and it's Adobe's reason that they're worth so much money. That becomes less attractive, especially to investors, when you can go and get a great return on your investment right now by putting it in a savings account. Now, investors don't put it in a savings account, they give it to the government by purchasing bonds, but a 6% interest rate or around that point allows them to make a return today. Maybe you've seen it in your own kind of bank accounts, make a return today, as opposed to investing in software that might make a huge return 8 years from now. So there's been a significant fall off in venture capital style investment in software products that might blow up 5-10 years from now. Notably, Be Real, that I'm sure many of you remember during COVID, the kind of thing where you share a picture from that moment, that day, everyone, that actually just sold for $500 million this week. That's a first like proper software, is it making money today kind of thing, sale in a while. So the market's turning, confidence that interest rates will steady and come down, but it ain't great. Where there is massive demand is in areas where spending money on developing software pays off today, either in increased revenue or in increased cost savings or in just increased performance of the overall company. Think things like finance and healthcare, energy, clean tech, government services. These are all areas where if you build better software and you're a finance firm, your users are happier today. Your users are, your savings portfolio is better today. If you're a healthcare firm and you build better software, your medical performance may be, hopefully, better today. You might be more productive today. So and they're more motivated than ever to do that because the big tech firms have reached a degree of market saturation in some of their areas, make it hard for them to continue to expand, meaning they look for new areas. Where do they look? Only domains, only areas that make so much money as for it to be worth it. If you're Amazon, it ain't worth you going into like, I don't know, it's not even worth you going into like a production, like, I don't know, a CRM or a piece of software. It's just not worth it. The maximum market is like 100 million. Sorry, 100 million, 100 billion. That's maybe the maximum you can get for a big CRM. Like a Salesforce is worth 180 billion. Like, that's the biggest in the world. So there's no point Amazon expanding into like CRMs or something else. So what I go for them to be worth their investors' time, they have to go for areas like healthcare or finance. Amazon spent billions on healthcare companies over the last couple of years. Apple's spending billions on investing in financial services. You bet they are. And they're just beginning. So all the incumbents, Chase, I don't know, Aetna Insurance, CVS, all these incumbents go, damn it. How do we make sure we don't have our lunch eaten by these big tech firms? So they're all building legit engineering teams. It's kind of exciting. It means you can go and work at JP Chase as a software engineer, as tens of thousands are, and you can have a great engineering experience because they know you're core to their business now. It's not the kind of old days, like, oh, the JP Chase software engineers out in the cold. No, it's a great engineering experience. A lot of their leadership was drawn from the Metas, from the Googles, as they did their layoffs and have become engineering leaders. They're bringing that culture, and you don't anymore have to sacrifice your engineering experience, maybe your brand, the kind of workflows you have, by going to those companies. So look a lot for those. You'll see it in the hiring. This is the last 500 offers out of Codesmith, and you can see a lot of like fintech, health tech, automotive, aerospace, a lot of Paramount Plus, media, these sorts of areas. Okay, every firm's a tech firm, except maybe you're not going to get too many from the conglomerates because they're still adjusting to the massive overhiring. All right, next. Where can you do it? Well, you're probably going to be, and apparently Codesmith grads are heavily overweighted towards remote and hybrid. This is not fully reflective of software engineering as a whole, but regardless, it's a heck of a lot of hybrid and a heck of a lot of software engineers being remote, and it's pretty hard to get on site only. So if you want that, you got to go looking for it. In terms of domain and seniority, increasingly you're seeing this generic software engineer, full stack software engineer, and and you can see a chunk get senior software engineer, but less of the front end only, back end only, partly because it's hard to define it. I don't even know what front end is. If you're building Google Slides, it ain't just about making it interactive with the user. Like they have like multiple threads of work, computation happening behind the scenes, all within the browser. They've got offline storage. It's a full stack application. So it's just harder and harder to define the difference between front end and back end. So just know that the titles, be really flexible on the titles, is what I'd say. Okay, perfect. So where can you do it? You can do it anywhere as a software engineer and probably have a good culture now. Maybe not the big tech firms at the moment. It's getting better. You saw some offers for Codesmith grads just in the last 2 months at the big tech firms, but it's far from where it was. And interviewing, like I was just hearing about a grad, and she just is interviewing at Facebook and Google right now. And yeah, she went to Columbia, but her major was not engineering. I can't remember what it was, but like, so it's getting better, but yeah, opportunities are less in those big tech firms. Can you do it in the office? Yes. Hybrid, on-site only, probably no. Remote, definitely. And then titles, a versatile set of titles, but being flexible on title is a good thing. Okay, so now let's talk. It's not a gold rush though. So why are you doing this? Well, let's talk about your why. I actually feel more. I learned to code, which is never a phrase I liked, but I became a software engineer because I wanted to be able to work with the key thing that problems were solved with, which was computers, software. I didn't want to be another person who like wished they could solve with that key thing. It hurt that it's got a great reputation, that it's got good regard and ultimately stability. We talk about people even in this room here who've been laid off, but and look at the tech market workshop we have. People in general, it's still a market where getting rehired is relatively, and we are in a 1 in 15, 1 in 10 year dip, and still, and I say this with my wonderful friend who just texted me a few days ago saying, I'd love to, you are intimately aware with the market, and I am unfortunately in the unemployed segment right now. And this is a great friend of mine. So it is mixed, but that's the point. Like, it's still as we saw, what is it? It's still 54 offers in the last, whatever that is, 60 days kind of thing. So it's still and it's still like the dream starting salary as a field. So what's going on here? It is not a gold rush. So you've got to work out your why so that when the win comes, it feels bloody great, so that you have the motivation to push through to the win, and so that you have the resilience over the career to grow and improve and evolve in the areas that are, that gives you that fulfillment. So working out your why. Is it that you want to have this job where it's just, I was on the phone on a video call with Tom Occhino, who is the co-creator of React and the chief product officer of Vercel that runs Next.js. And he's just a delightful guy, delightful person, motivated by including people in engineering. And he's like, my dream is that the lawyer can go and learn to code and implement their legal mind in software and in software engineering. Not only because it's multiplicatively effective, it does more stuff than the single lawyer might be able to do, but also it's just really fun. So do you enjoy that fun of always having to learn new things, always problem solving? Do you enjoy that? Got to find your motivation. So, I mean, this is the other one, which some of you will want, which is you want to build your own company or your own venture or your own freelance agency, whatever, with the knowledge of the core feature of modern society. It's just beginning, people. It's just beginning. How dominant. So much of the software built until AI was limited that it had to be, as I say, not probabilistic, not uncertain, not nuanced, meaning a lot of problems that we'd love to have solved couldn't be solved. You couldn't give legal advice. But what you do is kind of if this, then that, if this, then that. It could only be prescriptive. It could only be deterministic. It could only be dogmatic. It couldn't be nuanced, and therefore it couldn't really be useful. Now, you, with all the constraints and needs to do it right, can start to build software that solves the problem of giving customized legal advice. The amount of problems that are going to move to the domain of software where you as engineers will build those solutions is wild. So, that's why I did it, but finding your motivation. Okay. So we have how to be a great software engineer, where to do it, why to do it, and now how do you get paid to do it? So how do you get paid to do it? Well, half of it's being it. You've got to be a great software engineer. You've got to have experience in problem solving, experience in technical communication. And the other half is showing them, well, first half is showing that you are a great experience in problem solving. You have a great experience with technical communication, problem solving, PS, technical communication, TC, problem solving, TS, PS, sorry, technical communication, TC. And the other half is showing them that you are bothered, that you care. So at every stage of the application, you've got to do that. And it starts off so bloody unfairly hard. It's kind of nuts how hard it is. And it's not fair. It's not fair. It's not fair because it's really easy for some people. And those some people may have no more right for it to be easy than you. We'll talk about it. It starts hard, but it gets much easier at every stage. So here we go. Your job is to cross the chasm, ensure that the experience you have with what makes a great software engineer, problem solving, technical communication, etc., is perceived by another human being, the recruiter, the engineering manager, whatever, at the same level it's actually at. And by the way, this is the first thing to say. Many of you, maybe some of you oversell, but many of you are probably quite modest and end up, underselling, not describing your engineering in the way, let's imagine our friend Bojan, who had 10 years experience, doesn't put it in terms that are perceivable to another person, and instead puts them in the terms which would have been perfectly legitimate internally in the company Bojan worked for, worked for. Instead needs to put them in terms that are meaningful to another person. So you need to ensure that your level is perceived by somebody else as it actually is, not below and not above. But you're not going to probably get caught. You're going to get caught out if you try and do above, because they're going to in the on-site say, hey, do it. And you're not going to be able to do it. So much more likely you'll be underperceived than overperceived. These levels here are a little bit arbitrary, but roughly think 1, 2 is your can solve problems you've seen before with tools you've used before, sometimes called junior or entry. Level 3 and 4 can solve problems you haven't seen before as an engineer with tools you haven't used before, often called mid-level. It's the first sort of really autonomous, like you're taking on features independently from the start. And then the 5 there is your senior level, which is you're able to grow others and mentor others to solve problems they haven't seen before, using whatever tool they need to use. They may not have used it before. That's your senior engineer. They're the multiplier. And these levels are different in different companies. So just so you know, when I refer to senior there, that might not be called senior at Google. It might be called L4, which they call a mid-level. Their senior at Google and L5 is another step beyond. Might be more equivalent to like a principal engineer at a Bloomberg or other companies. You need to be perceived at the level you're actually at. To do that, you need 2 things. 1, you need experience with the things that they're hiring for. Above all else, problem solving, PS, and technical communication, TC. So you need stories of those. Well, actually, this is a bit too specific. When you apply, you need signals of them. When you're phone screen, you need stories. And when you're on-site, you need to do them. And as important, you have to somehow show them, especially when you apply, it's extremely difficult. When you're on site, you show them who you are. But when you're applying, you still have to show them that you are somebody who cares. You are somebody who's going to bring all this experience with energy to bear on their problems. Because it doesn't matter how good you are, if you're not going to be that bothered, it ain't going to work. They ain't going to be that valuable. You ain't going to be that valuable to them. If instead you're somebody who has the experience with the capacities that make a great engineer, what they're hiring for, and you're bothered, you're going to get hired so quickly. This is where I say it's unfair, is that when you're in the on-site, you can show them you care and you're dedicated. In the phone screen, it's a lot harder, but it's doable. In the application, you can't write, dear mom, sir, or whatever, hi, I am a dedicated and hardworking software engineer who enjoys problem solving and communicating technical concepts. If you write that, it's worth 0, and it might be worth less than 0, because they might even be like, show me. It flags them even higher, like, wait. You're telling me, but anyone can say that. And in a way, they then associate with you with everyone else, some of whom are not good. So how the heck do you show them that you are dedicated and care when you apply? We're going to see how, and it works. But I do want to say there's another way that gives this mutual admiration. And that is, unfortunately, getting into elite American colleges. Because elite American colleges in America are the most powerful signal. That's why they're worth millions of dollars. That's why places at Harvard are worth millions of dollars. That's why parents will donate millions of dollars and or play games, millions of dollars to get their child into certain schools, because it is the trump card signal that allows you, when you're applying, to show that you are, well, firstly, it shows you're good at problem solving. It's hard to get into Princeton. I put Princeton because it's turned me down, much to my chagrin. There we go. It's hard to get in. So if you've done it, wow, easily able to say you're a good problem solver and a good technical communicator, because it's hard to explain why you should go to Princeton, right? I'm being tongue-in-cheek here a bit, but this is subconsciously what every engineering manager is doing. They see Princeton, well, a good problem solver, it's hard to get in. Good technical communicator, because it's hard to communicate why you deserve to go to Princeton, so they must be. And in theory, they maybe think Princeton actually makes you good at it. I think it's more that they think it's a signal because they know how hard it is to get in. And then that's the other problem. It automatically attributes to you, if you got into Princeton or Harvard or Stanford or UCLA or USC or many schools, to be clear, but the value is very, very high at some of these schools, it automatically attributes to you, you must be really hardworking. You must be really dedicated. You are the kind of person, I don't believe in that kind of person thing. You are the kind of person who, when you get hired for my company, is going to bring your all. Not only are you good at the job, but you're also going to work really hard, because I know how hard it is to get into Princeton. And so people, I'm not saying it's not true. I think it is really hard. And maybe every person who goes to Princeton, Harvard, whatever, is really great and really hardworking. But in no way at all does it have any bearing on the person who didn't. In no way should it be that if you didn't, you are then unable to signal when you apply, I am somebody who has both got the capacity to be a great engineer, problem solving, technical communication, whatever, and will bring it to bear on your company. But it does, unless you have some other way to show it when you apply, to stand out from the crowd as the person who cares and has the capacity. So that's what we're going to focus on now. And it's using this technique called building your flashcard. It looks like people are still answering. Alex is answering questions in here. Thank you, Alex. Let's talk. Summer says, Shutsen Summer says, is what we are talking about more applicable to people that already had a few years experience that got laid off? Definitely to both, Shutsen, but I would also say, or Summer, sorry, I'd also say, yeah, definitely to both. Definitely to both, especially because you could say, hey, but I want to just go in and say, I don't know what I'm doing. Not literally, but like, I'm here to learn kind of thing. The market for those roles really is tough. And so it's better to try and, work out ways to be pitching a little bit more towards this sort of level, I think. Okay, let's dive in here, people, to how to do it. So you build your flashcard. So the flashcard, not that profound, but it's describing on one side, for every company you apply to, on one side, things that are special and distinctive about you. Maybe it's some problem solving you've done, specific example, and we'll talk about what those look like in a second. Ones that you can look at and go, oh, wow, that's some really hard engineering problem solving. We'll talk about how you show that in a second. Some example that is irrefutable on some really hard technical communication. In practice, we'll see once you get a bit further in the process, you don't need to write it, you're going to show it, you're going to do it. But when you're applying, you've got to have it that it's look at the flashcard and you can in 2 seconds expect that they will be able to go, oh, wow, they did that. And you all have that. Every Codesmith alum leans heavily on their open source tools they've built. These are things for other developers because those are very intrinsically considered difficult. And therefore the reader goes, you built it, it monitors what? Clustering architecture? Okay. Right, like instantly signals, but all of you have those too. And we'll come to how you identify those in a moment. On the other side of the flashcard must be, and as you go through the interview process, both of these sides are being filled out. On this side, things that you've done that are distinctive that they are aware of by the end of each interview. And on this side, things that are distinctive about their company that you have shown them you're aware of. So special things about you, special things about them. Why special things about them? Because special things about them that are truly distinctive are a powerful signal to them where you don't have Princeton on your background, that you are someone who is dedicated and cares specifically about their company and specifically about their engineering team. It cannot be things that are easy to retrieve. It couldn't be, I saw on the job description, your team uses React, because it's not a signal of your commitment, because it's too easy to find. It has to be something, and it has to be a collection of things as you go through the process, expand more and more, that you have built a bond with them on that indicates your genuine and sincere interest in their company. This side, special things about you. This side, special things about them. And at every stage of the process, you want to start to be communicating those. We want to be communicating those. When you apply, where you're going to get some sort of conversion rate from application to phone screen between 1% and 2%, you can do better, up to maybe 10%. Your flashcard should be as short as possible, because you're going to have to apply to a lot of companies, so you don't want to spend too long. But even when you apply, ideally, if you want to maximize your conversion, you want to be showing them when you apply both sides. Stuff about you that makes them go, okay, that's legit. And stuff about them that makes them go, huh, interesting. They think that's legit about us. That, you know, that must have been quite hard to find out. It's quite special. And we are quite special. Why do you do that? Because you have to show them that you are dedicated, that you care about bringing your talent to bear on their problems. When you apply, you can't tell them I'm hardworking. You can't tell them I'm dedicated. You can't tell them I care. You have to show it. The only way I know to show it is to do something that's actually difficult related to them. And it turns out that if you go and find out something, by the way, reach out to somebody in their team to have a coffee chat would also satisfy this, and then reference, had a great chat with. What you're doing is you're showing them via how damn hard this thing is, because it is hard, that you care. It is hard to reach out to somebody, but you're showing them by doing it that you are dedicated. And those are of equal importance. You're good and you think they're good, worthy enough of your time for you to do something difficult. What is the difficult thing? Well, it might be talking to someone on their team by reaching out for coffee, a virtual coffee chat. But it might also be, and we're going to look at how to do this, actually stuff that feels kind of a hack. It feels like that's not actually that hard. Am I faking it? I'm going to reassure you, it's very hard. And that would be mentioning something about the person's company you're applying to, the engineering side of it, whether it's a blog post you've read about their company and what their engineering's like, some problem they've solved, whatever, something they're describing in their blog, whether it's going on the LinkedIn of leadership and engineering leadership and seeing that the VP of engineering says, oh, really committed to mentorship in this team, and I like to stay on the ground and actually get involved with code at least every week. That goes on your flashcard for the company that you're applying to. Where's that show up? It shows up in whatever outreach you make to the company when you apply. Maybe it's a cover letter. Maybe it's a little message. Maybe there's no space for you to apply and it's attached to, I don't know, a DM on LinkedIn to the VP of engineering. Maybe it's a message to the recruiter alongside your outreach applying on the site. Maybe it's when you apply, I don't know, it's attached to your resume. It doesn't matter. It's that when you apply, you are signaling to the reader that you both are special yourself, but that you think they are special. Because people, as I say, I filter through hundreds of applications a week, and every single one that has ChatGPT generated or whatever, I mean, the thing that's a bit unfair is if they do, and they've got a really compelling background, fancy school, one goes, oh, maybe I'll do a phone call. Ugh, it's not fair. But what you're doing in your head is you're proxying. You're going, oh, well, I mean, they must be pretty diligent and hardworking. They got into USC. But most of us, and a lot of us don't have that. And if we don't have it, we are no less legitimate. We need to show, though, what we're really being hired for or what we're really being selected for when we have USC on our LinkedIn or our resume, which is not you suddenly became brilliant. It's that it's a signal that you are a dedicated, diligent, caring, hardworking person. Is it true? Let's be generous and say it's true for every USC graduate. Is it true that that means if you don't have that, you're not legit? It is far from true. But you need to show when you apply both sides. How do you show that you're legit? You show you're legit by some specific evidence of difficult problem solving and difficult technical communication. And maybe the other factors we said as well, like, you know, the domain knowledge or whatever. How do you show difficult problem solving? Well, if you go to Codesmith, you describe, I built this open source tool that monitors this interesting concept, this interesting thing, or that automates this task or whatever. It sounds legit, it's difficult, they know it's hard. And they might even talk about, for technical communication, I gave a talk through this sponsored speaker series, and they immediately go, huh, gave a difficult tech educational talk. Okay. They immediately take you seriously. If you don't have those, don't worry. You can look, just go and find the hardest thing you did in your prior job or in your computer science degree, or even, as we heard earlier, in your own projects. But it's got to be specific, and it's got to be how, what, why. What was the specific thing you were solving, with what technology, and why were you doing it in terms of some engineering goal? It's not, I have built a number of apps with Node. It's, we had to wrestle our data model while we were dealing with multiple API endpoints that each returned inconsistent data into something that was tractable within Node's runtime. That's a good example off the top of my head. There you go. But it's very specific. How, what, why with technology. What it's not, bizarrely, and again, this comes back to Bojan's earlier point, 10 years experience. Bizarrely, Bojan's 10 years experience, where Bojan writes, I did, multiple projects with multiple clients, actually is far less effective than Bojan saying, we wrestled with, and then a very specific, very difficult engineering challenge spelled out well and tightly, no more than 10 words, 20 words, would be far more effective than we worked on multiple various projects using various technologies. Because what they want to see is, what was the problem and how did you solve it? And you want to do that as tightly as possible, but you've got to do it in a way that's almost signaling. Signaling means you can get a sense of it in 2 seconds. That's what you got to do. Okay, so flashcard. At every stage, you need to show both sides, ideally, because they're hiring you for both sides. They're hiring you for, are you good? And are you bothered? Are you good? Well, we've talked about your examples. Keep them short and tight. They're going to be glanced at for a second. Are you bothered? You can't tell them I'm bothered. You have to show it by doing something hard about them, like doing a bit of research. We'll come to how you do that because it's the most pain in the ass bit. We're going to come to that in a moment. Once you get to phone screen, all gets a lot easier. Still not perfect, but a heck of a lot easier. What makes you special Well, now, unfortunately, you still can't show your problem-solving ability. Often it's a recruiter, it's on the phone. You can't like actually do some debugging and show your problem-solving ability and your technical communication ability, but you can tell stories about it. This is mission critical, this section here, people. This is as important as the first one in that it's not obvious. It's kind of counterintuitive. Once you get to on-site, I don't really have much advice for you. Just be good at engineering, which it sounds I'm being tongue-in-cheek there, but it's like be good at the job, which is all the stuff that you hopefully are by being a good engineer. Okay, like that's a different stage, right? But these two have some counterintuitive stuff. This one is ridiculous. The fact that you need to show your dedication by finding something out about them that's hard to find to show that you care. Pretty counterintuitive. This one's a little bit less counterintuitive, the phone screen, but it's still somewhat counterintuitive. Okay, you need stuff on you. Fill down the flash. By the way, when I say this flashcard, I'm talking like in the interview, you've got a post-it note that on the phone screen, you're going, make sure I've hit on these topics and make sure I've hit on these things about them. Or you could do it on a spreadsheet, whatever. But it's that, and you're building that flashcard out. By the end of the on-site, they should know a ton of things, or you should have recorded to yourself a ton of things they know about you and why you're special. And you should know a ton of things about why they're special, and you should have said them a lot, or said them, engaged with them on them. In the phone screen, though, you can't, your flashcard on why you're special is stories of problem solving you've done as an engineer and difficult concept, I guess explaining how you do them. Problem solving you've done as an engineer, explain how you do them. That means that when they ask you, tell me your experience, let's have someone up. Tell me your experience, Loretta, with, yeah, Chada, spot on. I agree with that. Tell me your experience, Loretta, the question might be, with Node.js. Or tell me your experience with React. Now, you might think that then you start telling stories of projects that you build and the features you... No, you instead need to describe specific reasons for why you've used Node to solve legitimate engineering problems. Because what you're trying to show evidence of is your ability to solve problems with engineering tools like Node. So when they ask you, tell me your experience with Node, your answer is not, I have 2+ years experience with Node, even if you have it. Maybe you want to mention, I've been doing it for a few years, but instead it's saying, taking a step back and going, when I'm thinking about my server runtime or my server environment or my server, I don't know, framework, there are a few things I'm considering. One might be the data model. What is the structure of data? What's the type of data I'm going to be using, working with? What's the primary goal of the server? It has profound effects for what server I should use. We've chosen in this recent thing I was working on, Loretta, this might be your third project or fourth, whatever. I chose to use Node because of these reasons. One, actually, we were just dealing with a series of server requests to a server. Thinking of those as a queue of tasks was quite a natural fit intuitively. And so Node, which considers as a single thread in JavaScript any requests as a task to be handled with a single function and then move on to the next request, was a really good mirror for how a queue works. That was a major reason we chose to use Node. And actually for our specific application where the requests coming in we were building out I don't know, what could be a Node server thing you were building out. We were building out it would process Bitcoin purchases. It was a small API request. Our API was able to then make a call to a Bitcoin server provided by another party. So each of these was a small task that we wanted to just pass off quickly, one by one, not get too bogged down and not have too heavy a server structure. Node's essentially queue was perfect for us. You see here, you're telling a story. So your phone screen is a collection of pre-prepared stories on the key technologies you worked with, and projects serve those stories around those technologies because you're really describing a story of how you solved problems. Really, your portfolio is never a collection. You don't get on the phone call and saying, look at my picture of my website. Instead, you're getting on the phone and saying, look at this story of how I solved this problem with the tool of choice that maybe produced a website. And you want 3 or 4 of those coming up in the phone screen. You also want to have 2 or 3 thoughtful questions on their engineering culture. This is your genuine interest and intrigue in them, which is half of what gets you hired. Are you bothered? Are you good? Are you bothered is a genuine intrigue and interest in them. And ideally, you're bringing up the thing you found out about when you applied. Like, oh, I did read this blog by your engineering manager where they talked about XYZ. That was really cool. And the recruiter goes, check, this person cares. Cool. But equally, you can do it by asking questions. How is your engineering feedback approach? Do you do some sort of code review process? I'm sure you do, of course, but what structure does it take? And the recruiter might very well be like, I don't know. You should talk to the engineering team about that. Amazing. But you know what that's also doing, people, is that's adding to the recruiter's side of the flashcard about you. Ah, interesting. This person cares about our engineer. And it means when you go to the on-site, you can say about them, i.e. your flashcard on them has expanded. I spoke to the recruiter in the phone screen and they weren't quite sure what the feedback process was, both code review and beyond. How does that work? I'd love to learn more. And then you've now shown them your side of the flashcard about them, your dedication, your interest and care in them. The other side is about you, your problem solving, your communication. Here's the key thing, people. Once you're in the on-site, it's just doing it. Yes, there'll be more storytelling about your experiences and how you problem solved, but you're just doing it. You're literally looking at a code base and trying to find the bug and talking through how you're approaching it. That's all about, have you spent the time developing these underlying things that make a great engineer? Of course, would be not a workshop, as Jay said, without saying, of course, you can do all those things at Codesmith, but you can also do all those things yourselves by all the community, broader community that you can get involved in, both at Codesmith, but also beyond. Okay, so final thing, and I know we've gone horribly over. Thank you, people, for being patient. But final thing here, let's talk about the how do you show this side of the flashcard, the rubbish side, the like, I promise I care side, that if you went to Princeton, you don't need to do as much, but you still benefit from doing it, but you need to do it less. Well, the easiest way is finding something about their engineering culture. For example, take a look at this great blog post from Riot Games about fixing bugs. And they talk about how they do it. And they do it all in this public blog post. It's actually really cool they do it, I think. But also, it's very cool to reference it when you apply. I loved reading, as you write in your application, I loved reading the blog post on how you fix bugs. What a great open engineering culture. Here's the funny thing, people, they care less about the detail of what you say. They care less about, are you reading it? I would say read through it, probably. They care more, bloody hell, this person even bothered at all. 97% of the applications we receive could be copy and pasted from another applicant. And that's the problem, people. They are worried you're literally a bot when you apply. They until they see some sign that you're going to be dedicated and care about their problems, you're this amorphous bot. Part of what the point of showing you're dedicated is, even at this early stage, and that you've done that bit of research, that you care, is to show them you're a human. Because especially when you can generate code with ChatGPT, albeit not very, beyond a limited amount, what are they really hiring for? They're hiring for the kind of person who pushes an organization, a feature, a bug fix forward. And that is about intrinsic energy and commitment. And that's what they want to see even when you apply. Did you show that bit of effort that took it from being a person who's not got any human intention / soul to be, I'm being silly, it's not that really, but that's how it feels to them. It could be literally auto-generated. Sometimes they'll respond to, and I've responded to messages, and then you'll realize, it's a recruiter, it's an agency, it's not a real candidate. They'll say, sorry, this candidate's no longer available. And you're like, well, shit, you know. So they desperately want to see, are you a person with intention, drive, care? That's what this is about. All stuff about you doesn't tell them that much. I mean, showing stories of problem solving helps because it's hard. So it is still a bonus. Saying I got 5 years React experience, that don't go very far because it's like, every other person who applies to the same thing. You might think that if you don't have 5 years React experience, you're at a disadvantage. Funny enough, people, the person who writes 5+ years of React experience is barely at an advantage. Because what they're trying to see is this person able to solve our problems with our custom version of React that we forked off the main version of React 7 years ago. So like, we don't really care about the tools so much as, are you someone who's going to wield whatever the tools are with energy and help us understand how you're doing it? And so the other way, so just the fact that it's hard to find the blog post is a sign to them that you bother. And then the other way to do that is finding something on their LinkedIn about the leadership team. Here we got like Corey Majin speaking about this company Vitamin in their LinkedIn user advocacy and engineering product teams. They might, I don't know what they said, but if we look this person up, we'll hopefully see. Hopefully we'd see something in here. VP Creative and UX, and they've got something here about, utilize design, advocate for users. So if you're applying to Vitamin, you might be like, oh, I loved reading Corey, the VP, emphasis on user advocacy and usability and how that plays into the engineering team, right? It's not so much what you're saying, but that you're saying something that was hard to find. And you might be like, that wasn't hard to find. You searched one line. People, hey, one day this is not going to be true. But every time I give this workshop, I say this same thing because it's so pathetic that I've still not done it. I say, I really want to get some great mentors for Codesmith, some great advisors. I just need to do this. Reach out to them, say, hey, love to get feedback on how we're approaching Codesmith. Not everyone's going to respond, 1 in 10 maybe, but I get some responses. Maybe 1 in 5, whatever, get some responses. Have I done it? I have not done it because I would need to do this. Find that little bit of extra to make it meaningful, to make them bothered to give me the time because I've bothered to give them the time, to make it worth their time. And the problem is I've never done it because it's that hard. And that's why I can tell you all these secrets, people. This is how Codesmith works. This is why Codesmith works. This is why, these offers come through. So what the heck are you paying for with Codesmith? Obviously teaching and all these things, but what you're partly paying for are team members saying, hey, did you send that message to somebody? Hey, did you keep going? Or the amazing alumni helping each other saying, hey, let's get on every day, do a stand-up on our progress in our job search. That's what you're really paying for. And that's not me pitching Codesmith. That's saying, God damn it, is that all it is? It's not just that, but it's a lot of that. But what's powerful about that, people, is therefore, if you can find that in you, you can do it without Codesmith. Okay? Because it's all about, and the same thing goes back here. How do you get good at problem solving? I didn't really dwell on this. It's by doing lots of hard problems and keeping pushing through and not stopping. It's when you want to get up and go and get a cup of tea, saying, oh, I'm going to keep pushing through this block. Again, you can do that, but will you do it? And that's why I went to a coding school in the end, to be forced to do the hard learning, to be forced to do the hard applications. So, but you can do it. And there are communities, 100 devs, that is run by a former General Assembly instructor, I think, that is open and free, targets underrepresented people in tech with this same, we can keep going, do the hard stuff. You can do it through organizations like the Hack for LA. You can do it through the CSX community. I'll give you all an invite to CSX where you can try and connect with people in the kind of Codesmith prep community, but you can use it also for just, being part of a community. Let me just send you all an invite in the chat here. But you see my point, people, is what people are hiring, but that's wonderfully within your control. That doesn't require you to know something different. It requires you to keep going in hitting hard blocks as you problem solve. With a good map, we gave you a bit of a map there, but there's other places you can get more of a map, or CSX or other places. And then once you've done that map, pushing through with these hard signaling applications. But that's not to underestimate it. It's the hardest thing in the world. I still bloody don't do it. So okay. All right, people. Thank you everybody for joining. Any more questions, folk?
Yes. Can you get the slides?
Yes, Garrick, of course. Thank you for jumping on. Yes, absolutely. I hopefully sent you that link there. Here's the slides, folk. I continue to love sharing these things. Okay, we've got one from Nancy Fab. Let's come to that. People, feel free to start jumping on.
And I have one last question.
Yes, Garrick, please.
Right. I have a friend, right? She sent me like a template, a file, right? Just the format of a website. And I was really wondering if I could like edit it and put in my own features and put it as my projects.
Oh, I mean, so Carrick, everyone heard that question there, people. Carrick said, hey, I've got like a template. That may be some pre-written code that my friend sent me, and I'm going to start to tweak and edit it and put it in as my own project. Carrick, engineering is the standing on the shoulders of other people who came before. There is not a code base in the world that isn't built on a ton of pre-written code. To the point, Carrick, you could even share, because again, it's not the website that's the thing you're getting hired for. It's the problem solving you did that produced that website, meaning you could even share in the bullet points of your resume, customized, overrode limitations, dealt with edge case limitations or restrictions of template. And that's good engineering. So, Kerry, you don't even need to hide it. It's a legitimate part of engineering, is taking templated code with all the restrictions and then customizing it for your own engineering ends.
Okay.
So, Kerrick, absolutely, but not even something to hide, something to speak to as part of engineering problem solving. Okay.
I really was thinking if it's like legal, like it's something possible. Because I actually use one of the templates and create like an agency website already.
Just do it. Go for it,
Well,
Kerrick. All right,
create
enough,
my own.
Kerrick. Good question. I'm going to mute you. No, good. Sorry, Kerrick. It's a very good question. It's a very good question. I want to just say to people, feel free now to jump off. If others like Kerrick have questions, we can start answering those. Thank you, Angelo. That's lovely of you. Oh, shoot. Let's make sure we don't miss any questions in the YouTube chat. I love saying the YouTube. It makes me feel like I'm really oh, shoot. Oh, see, look at that. It's almost in time. Oh, no questions in the YouTube chat. There we go. Okay, good. All right, we have Nancy's question. Oh, Loretta has a question. We'll ask Loretta's, and we've got Nancy's question. But feel free, people, to jump off now if you need to. No problems. I'll just make sure everyone's got my. Feel free to email me. There's my email, but I know no one uses email. Finally, that seems to be over. There's my LinkedIn. Feel free to contact there. There's my Twitter. Please go like, subscribe, everything. So we have Nancy's question. If I worked as a data scientist, mostly producing ML models, so pretty familiar with ML and stats concepts. Now, if I finish coding with machine, would I be good interviewing machine learning engineer? Or honestly, Nancy, it's so funny. I was saying this a couple of days ago. It's like, so this increase, I think this is going to be increasingly an angle. So there's a great thread on Hacker News about, what does one do in an ML job day to day? And the comments, well, a lot of them were like handling the data scientists and AI research scientists or scientists who can't configure their Python environment because they have not developed the software engineering mentality and approach. So actually, Nancy, at this point, I'm actually thinking this might be we might even do like a campaign around this, because we ran data science machine learning research group, and we took a bunch of PhDs in physics, things like that, who've done a lot of analytic work like ML models. They've done some pretty legit stuff: conditional variation autoencoders, deep neural networks, deep autoencoders, cut-based selection, decision tree. Like they've done boosted decision trees, like fairly heavy lifting things in their work with high energy particle physics kind of thing. But could they do anything out of a Jupyter notebook? You bet not. And actually, what's funny, they all got great jobs as ML engineers, data scientists, but ML engineer type roles. Honestly, much of the program was really making them good engineers. And it makes me realize actually, so we have a great grad who has just gone to be an ML engineer at TikTok. I think it's fine. I can probably share their Victor Liu. It's probably worth reaching out to this person, Nancy. So Victor is an ML engineer at TikTok now. So they were doing, I want to say, history as their major. Then they went to Codesmith, switched major to computer science, but they got that ML engineer role because of that fusion of, as you describe, ability to build models and ability to understand the constraints of the engineering system in which those are being built, which is an ML engineer. Now, do I encourage Codesmith grads to go straight for ML engineer roles where they don't have that data science and or analytic heavy background? No, I don't think so. I would tell them to go and do a 1-year data science master's or ML master's 2 years after, or a year or straight after Codesmith. But if someone's got the analytic piece, and to be fair, this person's only analytic piece was just, computer science degree, I think UVA, then they're able to pitch it. Because and now they did a lot of self-teaching on ML stuff. So if you already got that bit, but Codesmith itself is going to make you a software engineer ML adjacent, meaning you can work, and this is a separate talk, you can work on integrating LLMs, you can work on building out data pipelines, but you're essentially, I'm a software engineer, I'm not an ML engineer, but super high value intersectional role. If you have a heavier lifted data science background and combine it with engineering, well, you're an ML engineer. I mean, you're not far. It's designing servers, architectures, able to handle scale, deployed models, a lot of it's server design besides the actual model development itself. Great question, Nancy. Exactly. Full stack. Yeah, then Nancy, honestly, Nancy, can you give me a message on LinkedIn? Because I'd love to see your background. Send me your LinkedIn. I'd love to see your background. Sweet. Because I do think it's a booming area, which is data scientist who wants to become, as you say, full stack.
Yeah, totally.
Sweet. Fantastic. Loretta says, can you put me through a guide me to achieve the big complex project that would land me a job? So I would say, Loretta, obviously Codesmith does that, but that's a separate thing. The easiest ways are probably the easiest way is to look for the kind of hack for LA. It's anything with users is really helpful. Oh, you know what? Can you do this? Loretta, there's a Codesmith subreddit. Can you go to the Codesmith subreddit, post it there, and you'll definitely get responses of people saying, let's work on something together that is a difficult project. I'd do that, or the CSX Slack. There's a sub channel on there that you can start to, talk about working on projects together. So Kerrick, I'd do the same thing. Thank you for sharing the question there, Kerrick. Go on the CSX Slack, ask for collaborators. I would do that. Rob says, if I'm understanding correctly, sometimes a DS job is routine and not challenging, just queries, so you're seeking positions that are more intellectually challenging. So Rob, you're responding to Nancy's point. Yeah, I mean, data scientist runs all the way, but if you're looking to try and a lot of the value, a lot of the output of a data scientist is insight. Often, by the way, it's extraordinary insight that can make millions of dollars for a company, patterns they haven't seen before, right? Like, I mean, Rob, I'm sure you're saying this already, but if you want to productize it, and honestly, I mean, turn that insight, maybe it's prediction that can then be packaged as a user experience, that starts to become a heck of a lot closer to engineering. You're dealing with edge cases, you're dealing with user experience, you're dealing with reducing latency, you're dealing with messy user pipeline, a data pipeline from user. These all start to feel a lot like, and even not that, even if you're just searching and providing insights, that being done at a deployed level, yes, you might have a data engineer to do that, but also you're going to have an edge if you're able to do it yourself. But especially once it's becoming productized prediction. I wouldn't call necessarily dashboards, insights, research papers, which are all very legitimate parts of data science, but over here, maybe, I wouldn't necessarily say they have the same engineering demand or value to be doing engineering well. But if you're trying to use the same approaches to build a product experience, then it got to sit somewhere and it got to work. And work means, does it do what it's meant to do? That's different to data science. Data science doesn't have a imperative of does it do what it's meant to do. Its truth is in some way its insight, which might be, does it persuade the person? But it's, in this case, it's does it sit and work on a computer? That's product. And that requires an engineering approach. So yeah, it's moving that insight into deployed experience for user prediction of any kind. And that starts to look a lot like engineering. I mean, it's software engineering with the model piece, with the prediction piece. Sweet people, all right. We're out. Thank you, everybody. It's been lovely having you. Great questions. Thank you, Nancy. Please reach out. Thank you, Rob. Loretta. Thank you, Kerrick. People, feel free to reach out. And that is it, people.